The search for life in the solar system is expanding beyond Mars to the outer planets like Saturn and Jupiter and their moons. We really require greater and greater amounts of fuel to propel us into those areas of space.
Spacecraft are some of the highest performing and best engineered things that humans have ever designed. The way we're going to reach farther out into the solar system, the way that we're going to find life if it's out there, is by using better and better technologies.
Every bit of mass that you can save on the launch vehicle means you can put more scientific instruments on board.
For every 2 pounds saved on the structure of the lander, almost 1 ton is saved in the launch vehicle. It gives us an opportunity to answer one of the hardest questions of our lifetime, which is there life outside of this planet?
The goal of this project has really been to reduce mass and enable the lander to go further and further into space.
We've been working very closely with NASA's Jet Propulsion Laboratory to explore new concepts in how we can design interplanetary landers. What's really exciting about this project is this is the biggest and the most complex thing that's ever been done in generative design.
Initially, the engagement was somewhat of a curiosity in terms of research for them. They were excited about potential 10% mass savings. That's on the order of what they can do. Everyone was surprised when we were able to demonstrate 30, 35% mass savings. That really opened up a whole new range of possibilities.
This lander, this whole assembly, really pushes generative design to the very, very limits of what it's capable of. We're working with JPL to really develop the tools of the future.
Traditionally in design, you would go through a manual process of identifying your components, identify where the components are located, and then building structure around that. With generative design, we identify the critical pieces and locate them so we can actually optimize for, say, packing a payload.
For this kind of structure, the benefits that generative design provides are not simply about weight saving. They also allow engineers to much more quickly iterate on the design process. It allows the design to be more flexible and for introducing more design intent into the problem definition.
With generative design, it gets to open up your mind. You start looking at these problems saying, wow, that's a really interesting way to do that. Now I got to figure out how to manufacture it.
You can see examples of generative design in additive, in subtractive, and also in casting. The ability to really leverage that problem definition up front allows us to do a plethora of design options rather than just reduce one design down to its most optimal form.
Applying these new generative design technologies to such a high performance and important problem is something that's tremendously exciting, and it's going to be these technologies that let us get out there.
We've really pushed the limits of mass reduction, and that's significantly magnified when you think of how much fuel or how much more science we can fit into that lander. The things we're working on today at Autodesk can really inspire in that search for life beyond our Earth.